Hello everybody, and welcome to another lecture on computer architecture. Today I'm going to show you a full live example of the MOS65xx assembly. But one thing is nice to show an example that is just everything is in text. But the other thing is to show a real live example and to have it really compiling, or that is to say assembling and running on a computer. The problem with this is that the hardware of the 6500 is no longer readily available. But what we can do is actually to use an emulator. And an emulator, in this case we're going to use, is VICE, which is a full Commodore 64 emulator in which we can then run our assembly programs as if it were the Commodore 64 itself. Where were we? I already had posted a video about how to install VICE. However, I made there a small mistake. That is to say, it worked at that time, but things have changed and now the setup is a little bit different. The first thing you have to do, so let me repeat it here a little bit. The first thing you have to do is install the VICE emulator, Versatile Commodore emulator, from the software manager. This is, I am running here Linux Mint, but in other versions it should be more or less the same. Don't look for VICE itself, because then it will not find it. Look for Commodore, then find VICE, and then you can actually install this software. Now, after you have done that, you can also read then actually the comments that are written there. You also have to install the ROMs. The ROMs, read-only memories. It means actually what we nowadays would call the BIOS, which is the basic input-output system or software. That is because otherwise you will have an empty computer which cannot run anything. You need some basic instructions. And the problem with this is that this software, this BIOS, is actually copyrighted, so they're not allowed to give it to you. But if you look on the internet, you will readily find, just look for VICE 1.5 ROMs or something like this, and you will readily find these ROMs available. I managed to find it, so you should also be able to do it. The problem is that last time I said that you should put them in your home directory, which of course in Linux is nicer. But now that doesn't run anymore, so now you have to put it in a directly the root directory. So you need super user permissions to put it there, and that is in the directory user lib vice. So you will then have something like this for all the Commodore devices. You should actually then have Commodore 64 and all the other computers. Once you have set it up and this is in the correct directory, then you can do other and you have Commodore 64. And as you will see, then it will have this Commodore 64 environment. So this is how it was in the 1980s. I want to remind you that this is still the most sold computer ever, with millions and millions of copies sold. And it was connected to a television to save cost, that you not have to buy a monitor. So you get something like this, low resolution for modern standards on your television, and you get something like this. And to show you that it works, let's write a small basic program that we write. Of course, we already know what we're going to write. Hello world, exclamation mark. So we have, it's actually running a command line. It is actually basic. And we can now run it. So we have here hello world. Well, for us, of course, from computer architecture, we want to take it a little bit further. So we have to find an assembly. And at that time, the 6500 assembly, there were a lot of assemblers, but we also want an assembler that still comes with some kind of manual. So I found one that is called Merlin, and is written by, let me see here, Glenn Braddon. And the advantage is this, that you can also still find books from that on the internet, which I managed to find. So then the problem is where to find the assembler itself, the Merlin assembler. Well, you have here in Commodore software, you can find all disks that were, or a lot of disks that were from that time. And I found here the Merlin 64 assembler disk. So now we have to install this in the virtual disk we put in a virtual disk drive. So I have to attach here a attached disk image. I put it in drive 8. Which one do I want? I have here the Merlin assembler. So now I have placed virtually the disk in the virtual drive, and I can actually see, I can actually load it. This went like this. And as you can actually hear that, let me see, not sure if you're going to hear this, but actually the disk drive itself is also, the sound is also emulated, which I find quite funny. Anyway, it has now run the directory of this disk drive into memory, and I can now say actually run. So I hope that you now can hear it. The disk drive is making sound. Well, let me switch off the sound to not interfere with us. In the meantime, it is running the program. So you can see that it's also the speed, well, that was how it was at that time. It is loading from a floppy disk, and that is quite slow, so we have to wait some seconds. And then the assembler will start running. We will get a gray screen. I hope this will be in a moment. Once we have the compiler running, there we have it. You see Merlin by Glenn Braden, that also wrote this book. It's from Roger Wagner Publishing Incorporated. Well, we have this environment. It switched the screen to gray. That's okay. Now we can actually load our program, our assembly program, the source code, which I already did. So let me put that into disk drive number 9. You can actually have, as you can see, you can have 3 disk drives. I put this one in 9. Something else I want to show you, that if you want to change the settings of this disk drive, it's here. Configure drives, and the drives that I'm using is CBM 1541-2 for drive 8 and for drive 9 as well. And I put there this sound emulation, which I found quite funny, and save settings on exit, of course. So now we have 2 virtual disk drives with in each disk drive a virtual disk. So what we can do now, I changed the disk drive to number 9, where is my source code assembly code. So let me see if it's there. Yes, it's called hello.w.s source code, which I can now load with L. Hello W. It will run it, and it will go immediately to the editor, which I don't want. So let me go quit from here, and I want to show you here. On this side I will put here the commands that you can then do. I'm hoping I'm not sitting in front of it, but anyway, now we can go back to the main menu of Merlin, and I can go into the editor and list with L. I can list the program that I've just loaded, and you can see this is the program. It's very small. What it is doing, it makes the background or the border, it makes it white, and then write hello world on the top left corner. Let me show you how this is done. Well, first of all, the first line, the lines themselves here, they're not code. This is just printed here for our convenience. The code itself is written then in a column. The first column is in principle is labels. The second column is in principle is then the opcode or the mnemonic, and the third column is the operands. So in this case it starts with an asterisk, meaning that the rest is ignored. So we can use this for comment. Then the second line is doing org 8000 hexadecimal, and that means that when compiled it will be immediately placed in memory in memory address 8000 hexadecimal. Then we have here label character out. This is equivalent, a compiler directive, meaning every time it finds this word, it will replace it by this value. The same for setCUR cursor. It's equivalent to this hexadecimal FFF0. Border color, it's equivalent to hexadecimal D020. And the real first instruction starts on line 6, which is LDA, load into accumulator or into A. Direct, so direct addressing mode, immediate 1. Line 7, store the contents of the accumulator into BRDCOL, which of course we have defined here as being address D020. Okay, then we load immediate 0 into register X, load 0 into register Y, and then clear carry and do a jump subroutine set cursor. So it will set the cursor to position 0, 0. If we not had done clear carry, then it would have actually read the cursor position. But never mind, it was now we have set the cursor. Then we put load x 0 again, load into A the contents, so this is indexed, the contents of address data+x. So that is the x starts with 0, the address data, which is defined here. Here we have the data segment starting from 19, 20, 21, 22, where is stored hello space world. Hexadecimal 0 at the end. Oh, there's missing 0 here. I should now edit line 22 because it is missing 0. Hex 0. Okay, so you can see here already how you can actually edit. 0 is the string terminator, as you know. So what it is doing in a loop, it is incrementing the x value and then reading the data segment 1 byte at a time, and actually then going to subroutine to character out. So it will output one character and then go back to loop, increment x, and then go back to loop. And it will do that until the character that is being read from memory is actually equal to 0. In that case, it will jump to done. So this is a very small program that we now can compile, which we do by ASM. It will now do update source. I want no. That operand in line 22. Oh, it doesn't want that one in line 22. So I guess it wants a hex, and we have to give 2 values. Let me see if it can still do list. Yes, now it has 2 zeros, and we can assemble it. Okay, it has assembled our program. That is nice. So now it actually already placed it in memory, which I can see. I can go into the monitor. When I'm in the monitor, I can see my program, 8,000, I should say 8,000 L. And you can see here now the address. The first column here is address. Then it is the machine code in hexadecimal. Then it is written here. If this machine code is interpreted as instructions, then it is this column. If it is interpreted as ASCII, then it is in this column. And of course, the first lines of our code, they were in the indeed instructions, and the last part of our code, where is the data segment, there is written, as you can see, hello world. So now we're going to run it. How do we do this? We just say where we want to. Why does it give so much zeros? I don't know. 8, 1, 2, 3, go. And as you can see, it has made the border white that we did with changing the border color, and it has written hello world here on the top. So this is shows you how to write assembly in Vice, that is to say in MOS65xx family assembly, and we have used the Vice Commodore 64 emulator to then show how this was done in the Commodore 64. Okay, see you in the next lecture.